So when is a Mustang running hot, but not actually running hot? When the gauge isn't working right. So my name's Walter. This is the GT350 Garage. I'm finishing up the cooling system on my 66 Shelby, and in this video we're going to talk about gauge function. A lot of guys will simply jump straight to aftermarket gauges because the factory gauges on these cars have kind of earned a reputation for being unreliable and untrustworthy. I disagree. I think the gauges work fine as long as you know how to keep them working the way they were designed to work. So to do that, you have to know how they were designed and how they were designed to work. So let's talk about the factory gauge system in an early Mustang. And this applies to basically all Mustangs from 1964 and a half through about 1985.
So what we're looking at here is a wiring schematic that's pretty representative of most typical gauge systems from the 60s and 70s and applies basically to most manufacturers. In the case of our Mustangs, we have three main components in the gauge system that are really critical to the gauges working properly. That's the constant voltage regulator or instrument voltage regulator, the gauge itself, and the sender. Now, obviously, the wiring harness needs to be in good shape, otherwise that's going to create a whole different mess. But basically, all of the gauges, with the exception of the ammeter on an early Mustang or any Ford product of that era, all work using the same exact inner workings. And all of the senders are designed to produce a resistance value in the same basic range. So your senders will be 73 ohms to produce the lowest reading on the gauge and 10 ohms to produce the highest reading on the gauge. So to learn more about this, let's get into how this stuff works.
Okay, so the way the gauges were designed on these cars, they are a throwback to Ford's gauge technology going back 40 years before this car was built. They're basically designed to work on a 6-volt system. And that means that there's a device on the instrument cluster called a constant voltage regulator or an instrument voltage regulator. The two names are interchangeable. And that device is designed to produce a constant output between 5 and 6 volts. Closer to 5 normally, but sometimes it'll get up to 6. Okay? Now there's 3 wires going to that. You have one wire that's coming from a key-on power source. That's battery voltage or the full voltage of the charging system, depending on whether the car's running or not. You have an output wire going to the gauges, and then you have a ground connection that goes from the instrument voltage regulator to a ground location on the firewall. Those 3 wires are very important to the function of the instrument voltage regulator. So, if your instrument voltage regulator is not functioning properly, it is going to skew the gauges. If the voltage goes up above 6 volts, you're going to see much higher readings than you should. As an example, if you saw 12 volts, the gauge would read hot when the engine was only at half of its maximum operating temperature on the sending unit. Okay? So it's really important to check that voltage. Now to check that voltage, you're going to disconnect your electrical connection here at the sending unit. You're going to hook up a voltmeter between the negative terminal of the battery and the sending unit wire, and you're going to read the voltage on a digital voltmeter. And it should be between 5 and 6 volts. If it's more than 6 volts, the first thing you want to do is check the ground on the constant voltage regulator, both at the gauge cluster and on the firewall. Make sure you don't have a bad connection. The next place you want to check is the ground connection at your firewall to the back of your engine. And finally, from the front of the engine block where the negative battery cable is connected to the battery. That portion of the circuit has to all be functioning correctly for the instrument voltage regulator to do its job. Okay? Now, if you've checked all those connections, they're clean, free of corrosion, they're good solid connections, then I would suggest you'd probably want to replace the instrument voltage regulator. They run about $40 on average. You can get them from your favorite online vendor, or you can get them locally at most parts stores. Worst case scenario, in a day or two if they don't have one in stock. Okay? So we've tested the instrument voltage regulator. The instrument voltage regulator is good. Then if we have an erroneous reading, there's only two other things it can be. The next thing I would check is the sending unit itself. Now, the sending unit on these cars is in the water crossover on the intake manifold.
So I've loosened up the sensor and I'm going to remove it here. And what you can see is that this sensor is covered in corrosion. Now, the coolant temperature sensor in your early Mustang is a thermistor. A thermistor is a type of resistor that changes resistance with temperature. In this case, the hotter the coolant gets, the lower the resistance gets, and that's how it makes the gauge change its reading. This resistance and corrosion will have gotten down into the sensor, and you can see it on the terminal stud, and that's going to cause the gauge to read colder than it's actually should be reading. None of this came from inside the sensor or through the sensor, because you can see from looking at it here, it's solid on the bottom and there's no way for coolant to get in.
So now I'm going to see if I can show you. The corrosion has also gotten into the connector. I'm going to have to clean that out, check the circuit, and I may actually have to replace this this terminal. I think I have an engine harness for this car, and I might just put the new engine harness on the car, because this is bad news, folks. If you have green crud growing in your electrical connections anywhere on your car, that added resistance is going to screw with whatever you're trying to accomplish. So here's the new sensor. It's nice, it's pretty, it's clean, it's brand new, it comes pre-taped, it's ready to install. Some people will say that you need to install it with no Teflon tape and no sealant, because you don't want to increase the resistance of that connection point. This is where I'm going to disagree with those people, and I'm going to tell you that because it's a tapered thread, the sealant is going to do its job and seal, but you're also going to have enough metal-to-metal contact through thread tape or a little bit of silicone that you really won't have a problem getting a good quality ground for the current level that we're running to operate the gauge. Before we connect this sensor, we're going to take care of the harness and make sure that that's addressed first. So the new sensor comes pre-taped, ready to install, and it just takes a second to put one in. You can actually get away with doing this if the car has a good radiator cap. You can usually pull these out and not drain the cooling system, which I know that's kind of a wild idea, but if the car has a good radiator cap and the system is sealed, there will be a vacuum in the cooling system that allows
the coolant to stay put in the intake manifold and lets you change the temperature sending unit. So that's just a little tip that might help you out. Don't try and change the sending unit on a hot engine, or you'll have a geyser coming out of the intake manifold and it'll be all over the top of everything. Always change them on a cold engine.
The gauge works in a range, okay? And the range is determined by the resistance that comes from the sending unit. The sending unit is designed to produce 73 ohms, roughly, at 130 degrees, and 10 ohms, approximately, at 250 degrees. Now, that can be a little bit one way or another. One way that people will often look at that is at 10 ohms, you'll be at 250 degrees plus or minus 15 degrees. At 73 ohms, you'll be at 130 degrees plus or minus 15 degrees. So as long as you understand that there's some room for error and a little bit of variance, you can approximate your temperature and get a rough idea of where your gauge should be based off of the temperature that you can take from the intake manifold and the resistance of the sender. Now, the final component is the gauge itself, okay? And one thing you can do to kind of get an idea of whether or not the gauge is functioning properly is, with the key off and the negative battery cable disconnected, you can test between the negative battery cable
And the sender connector.
and you should have between 40 and 45 ohms of resistance. That's a simple measurement. It's a good way to check and see if you have good continuity and approximately the correct resistance in your gauge. And if that's the case, then you wouldn't need to worry about changing your gauge. Let's talk about what your other options are in the way of gauges. So there's lots of different aftermarket instrument clusters available for these vintage Mustangs now, and none of them are bad. If that's the route you want to go, by all means, choose what you like, install it, and enjoy your car. If you want mechanical gauges, buy some mechanical gauges, install them in your dash, and go for it, okay? I have nothing against these options, but for anybody that doesn't want to have to deal with running a mechanical gauge bulb with the capillary tubing through the firewall out to the engine, and then deal with routing it around throttle linkage and making sure that it doesn't get in the way, the stock gauges can work more than adequately. Same thing with your aftermarket gauges. If you don't feel like spending a bunch of money on aftermarket gauges and you just want the stock gauges to work, I would recommend that you do some quick electrical tests and verify that the system is working. Replace your IVR if necessary, put a new sending unit in it, even replace the gauge if you need to. Now, all of these things are options. Replacement gauges, sending units, and IVRs aren't terribly expensive. It's cheaper than aftermarket gauges. But again, go with what works best for you for the way you want your car to be. I'm not trying to sway anyone into thinking that a stock gauge is better than a good quality modern aftermarket gauge. There's no denying a modern aftermarket gauge is going to be superior to the original factory piece. But that doesn't mean you have to have that modern aftermarket replacement. You can still use the factory stuff more than adequately. Mechanical gauges, of course, are always going to be a good choice. Running a mechanical gauge, you're going to have a fairly appropriate reading for wherever you place the gauge. The one thing I will say is, because of the location of the gauge sender on some of these intake manifolds, it's going to be biased to one side of the manifold if it's on the driver's side of the distributor. It's going to see the temperature off the driver's side cylinder head more than the passenger side. I definitely don't recommend putting the sending unit on the outlet side of the thermostat housing. That's not where you want the gauge. You don't want the restriction in the hose, and that's what it's going to be, is a restriction. Also, you're going to see large fluctuations every time the thermostat opens and closes. Now, let's go back and touch on thermostats and their relationship with the gauges really quick. When these cars were built, they came with a 192 degree thermostat from the factory. Now, very early on, a lot of people changed them out for 180 degree thermostats to try and cool the cars down, because the minute they saw that temperature needle go past the halfway mark, they started freaking out and they thought the car was running too hot. The stock thermostat opened at 192 degrees and was fully open by 212 degrees. That's a 20 degree range, okay? So it took 20 degrees to get that factory Ford thermostat all the way open. So it was a fairly slow thermostat. With a modern thermostat, like the 195 degree Robert Shaw that I'm running in here, it's a high flow thermostat, it's a fast acting thermostat, it's designed to open quickly. Within a matter of 8 to 10 degrees, it's fully open, not a 20 degree range like the factory original was when Ford built these cars. So, using a modern thermostat design and going back to the 192 to 195 degree range thermostats is actually going to get your cooling system operating the way it was intended to operate from the factory. And your temperature sender is going to then be operating in a system at the temperatures it was designed to operate in. So you should see a temperature with the needle at the midpoint of the gauge, and the needle should not fluctuate drastically, okay? Once the car warms up, the needle should stay relatively close to center at all times. You might get down to the 1/3 of the way from cold to hot, and you might get up to 2/3 of the way from cold to hot occasionally. But you shouldn't see a drastic change in the operation of your gauge if you're running the hotter temperature thermostat like the car was designed to run with. You'll see a bigger sweep of the gauge when you're running the colder thermostats like a 180 or a 160. A 160 degree thermostat, if you manage to get it to close, the gauge is going to have dropped down to about a quarter of the way from cold to hot. Then it's going to creep back up, and then it's going to cool back down. And you're going to see a lot of movement on the gauge with that cold thermostat if the system is capable of working with a 160 degree thermostat. Your best bet is to run with a warmer thermostat. 180 is bare minimum on these early small blocks. 192 to 195 is what they were designed to run with, and it's what they should be used with. So with that, I hope this helps you guys understand how the factory gauge works and gives you some insight into whether or not you can tolerate using the stock gauges, or maybe you do want to go with that aftermarket solution. You know, it's entirely up to you. It's entirely your decision what you want in your car. But this is how the gauges work. Now, aftermarket gauges, quick note on aftermarket gauges, they do operate on a 12 volt system. They're designed to work in a 12 volt system. They are not 6 volt gauges that have been reworked to work in a 12 volt electrical system like the factory gauges. So you will not have an instrument voltage regulator in an aftermarket gauge installation. That's one thing you do need to keep in mind. Other than that, mechanical gauges are great. If you want mechanical gauges, go for it and choose what works for you the best. But if you want to keep the stock gauges, you absolutely can. So I hope you find the information in this video on using the factory and aftermarket gauges to be helpful and informative. If you have any questions about what I'm describing, the tests that I'm performing in this video, by all means, reach out to me through the comments and leave a question, and I'll do my best to answer it and explain it in a way that can work you through the problem that you might be having. If you like this video, maybe you learned something new, maybe it's helped convince you to try and do some more work on your own project, leave a like. I appreciate that greatly. I like any and all feedback that I get. If you haven't already, subscribe to the GT350 Garage for more content like this, and ring the bell so that you'll get notifications when my next video posts. For more information about my Shelby build, you can also find me on Instagram and Facebook. The links are in the description below. And as always, I thank you for watching, and I hope you'll join me for my next video.